we get something closer to this.
Okay.
So what's happening when we go from this to this? What do you suppose our sign for the delta S is? We're going this way.
Positive.
It looks like it's going from order to disorder. I mean, from disorder to order.
It's going from disorder to order. So this would have a delta S would be,
Less than 0.
we got to get this right. We're,
Oh, because things go from.
he's exactly right. We have disorder and we have order. So if the system is becoming more ordered, are we increasing or decreasing the entropy?
Decreasing.
We're decreasing the entropy. So delta S would be
Less than 0.
negative.
Or negative. Less than 0. Ah, I see.
Yes.
I see.
Less than 0 would be negative.
You're negative.
Okay. So what happened when we went from this to this?
Disorder to order.
Entropy decreased. What did it feel like?
It's so cool.
It felt warm. When we went from order to disorder, what did it feel like?
Cold.
Cold. Let's think of this not as a polymer, but let's think of it in terms of water. This would represent water vapor, and this would represent liquid water.
Are you trying to show us the correlation between like the flow of energy and the flow of entropy? Like,
Yes,
Okay. Then
I am.
I think I know.
I'm trying to explain some physical phenomena that you encounter every day and don't even know it.
Global warming?
No,
Cool.
ain't nobody got time for that. All right. Shut up. Let's say we have water going from the liquid to the gas. What's that feel like? You have felt it.
It's gonna get hot.
Make it hot.
Evaporation, vapor stuff. Humid.
Why do you sweat? To cool your body. What does the water do after it comes out of your little sweat glands?
It
It
evaporates.
evaporates. It goes from liquid to a gas.
Oh my god, it makes
That
sense
takes
now.
these molecules that are higher energy level than these molecules. So to go from a liquid to a gas, it needs energy. Where does it get that energy? From you. And it feels cold. It's an endothermic process. So it draws energy from you. The sweat on your skin goes from a liquid to a gas, it feels cold. Just like when you had the stretched out balloon and you let it come back, it felt cold. That was an endothermic process. Okay? So when water goes from a gas back to a liquid, it's going to a lower energy level.
Therefore, heat up.
These molecules have more energy than these do. In the rubber band, it had potential energy. Okay? So these molecules have more energy than this. In order to go from gas back to a liquid, if we're talking about water, it has to give off energy. Remember my question about what would you rather stick your hand in? Water, liquid water at 100 degrees Celsius or water vapor at 100 degrees Celsius? What was the correct answer?
Liquid water.
Liquid water. Why?
They don't keep getting you, like, they keep running.
Yeah, they're
No.
not continuously. I thought that's
No.
what it said. They're not continuously colliding.
They're both going to burn you once because they're both at 100 degrees Celsius.
Oh, because the water vapor will hit you and then it'll
Your
burn
arm
you.
would cool the water vapor,
Yeah, and turn it into
and
hot
some of
water.
it would go from gas back to a liquid. Good, you remembered something. So that is an exothermic process. You get burned once because it's hot. You get burned again because it's changing phase. So if you ever have the choice, stick your hand in boiling water, not water vapor at 100 degrees
I'd
Celsius.
like to play a game.
Huh?
It's getting
Well,
hot.
that would cause hypothermia. That would have its own perils.
You'd be sick.
Okay.
Missing that.
Does anybody have a refrigerator at home?